Today, we are diving deep into the world of credit card fraud detection, and we're going to explore a really fascinating AI approach that's completely flipping the script on how we catch the bad guys by doing something that sounds totally backward, using less data to get smarter.
So, you know that text message you get from your bank, right? The one that says, hey, did you just spend $50 on, I don't know, llama-themed socks 3 states over? It's a common experience, and it definitely gets your heart pumping for a second.
But have you ever really stopped to think about how it knew? How on earth can an algorithm sift through literally millions, maybe billions of transactions to pinpoint that one weird purchase you just made? Well, that's where the story gets really, really cool. See, the biggest problem for any AI trying to spot fraud is this. It is the classic needle in a haystack problem. Fraudulent charges are incredibly rare compared to the absolute mountain of perfectly normal, legitimate purchases we all make every single day. In the world of AI, this creates something called an imbalanced dataset. Just think about it. The legitimate transactions, that's our massive haystack. That's the majority class. And the fraudulent ones, those are the tiny little needles, the minority class. So if you train an AI on this data, it naturally gets biased. It becomes an absolute expert at saying, yep, that's a normal purchase, but it's pretty terrible at spotting fraud because it's seen so few examples of it.
So, the first idea that comes to mind seems pretty simple, right? If you don't have enough needles, well, just make more of them. This technique is called oversampling.
One of the most popular ways to do this is a method with a funny name, SMOTE. You can think of SMOTE as kind of a digital forger. It looks at the few real examples of fraud that it has, and it cooks up a bunch of new synthetic ones that look super similar, all to try and even things out for the AI.
But here is the massive catch. And this quote just nails it. It's like photocopying the needle. Yeah, you've got a bigger pile of needles now, but they're all just fuzzy, blurry copies of the original. This actually introduces a ton of noise into the data that can end up confusing the AI more than it helps.
This leads to a classic problem in AI called overfitting. The model doesn't really learn the pattern of fraud, it just memorizes the training data you gave it, including all those blurry photocopies. So it gets an A+ on the practice test, but then it completely fails when it faces a real, brand new scam out in the wild. The big takeaway here? More data is not always better data.
And this brings us to the really clever, kind of mind-bending idea. What if the answer isn't to add more fake data, but to intelligently remove some of the real data? This is called undersampling.
And you can really see the difference here. On one side, you've got oversampling. It's trying to bulk up on fake fraud examples, but it risks adding all that noise and confusion. But on the other side, you've got undersampling, which does the total opposite. It carefully trims away some of the legitimate transactions to get rid of the noise, making the real pattern stand out.
Think of it like this. By getting rid of the legit transactions that look suspiciously similar to the fraudulent ones, you create a much clearer decision boundary. You're basically cleaning up that confusing gray area, making it way easier for the AI to draw a sharp, clean line between what's safe and what's a scam.
And this is where the hero of our story comes in. Researchers developed this really sophisticated method called EFC-Tomek, which is a powerful new way to do this intelligent data weeding.
At the very heart of this method is a concept called Tomek Links. Okay, so a Tomek link is basically a pair of data points, one legit, one fraudulent, that are sitting right next to each other in the data, and they are each other's single closest neighbor. These pairs are like big red flags pointing to that blurry, confusing boundary. So how does the cleaning actually work? It's really elegant. First, the algorithm finds these pairs of nearest neighbors from opposite classes. Then, it checks to make sure the relationship is mutual. Yep, they're both closest to each other. If they are, boom, that's a Tomek link. And here's the magic trick. The algorithm then deletes the one from the majority class, the legitimate transaction, which cleans up the border.
And the result of all this? You got a much cleaner, more refined data set. The fraudulent transactions suddenly stand out because all the noisy, confusingly similar legit ones are gone. We've basically thinned out the haystack, making the needles so much easier to find.
Okay, so the theory sounds amazing, but does it actually work? Well, the researchers put the EFC-Tomek framework to the test on a huge, real-world dataset of European credit card transactions.
So, what happened? They tested a few different AI models on this newly cleaned data,
And while they all did pretty well, one model, the Artificial Neural Network, or ANN, just crushed it. It got incredible scores on both accuracy, which is how often it gets the right answer, and recall, which is how good it is at finding all the actual fraud cases. And this chart just makes it crystal clear. You can see that the ANN model pulled ahead of the others, hitting the highest level of accuracy when it came to correctly flagging fraud. Let's just stop and look at that number for a second. 99.36% accuracy. That's the result of all that clever data cleaning. It is an absolutely outstanding level of performance, and it proves just how powerful this less is more approach to data really is.
So what's the big picture? Why does this technical deep dive actually matter to you and me?
Well, let's recap real quick. We started with this huge problem, imbalanced data. We saw that the old way of just making up fake data can actually make things worse. Then we found this new, smarter solution, intelligently removing data. We met the EFC-Tomek framework, which is the tool that makes it happen. And the bottom line is simple. Better data leads to a smarter AI, and that means safer money in the bank for all of us.
And the researchers themselves said it best. They concluded that this ability to go in and sharpen the boundaries between what's good and what's bad is an incredibly powerful tool, especially when the stakes are as high as they are in finance.
And that leaves us with one last, really fascinating question to think about. We just saw how less data can make an AI smarter at finding fraud. So, where else could this powerful, counterintuitive idea work? What other needle-in-a-haystack problems could we solve not by adding more, but by intelligently taking away?